solution. So here the two smooth inclined planes, inclined at 30 degree and 20 degree each, and two mass is kept that is 10 kg and 5 kg. So this is the mass A and this is mass B. This is connected using a string over a pulley like this, and let T be the tension. So we will consider individually the free body diagram. So first of all, free body diagram of mass A. So this is mass A. Now the weight is acting vertically downwards, which is 10 into 9.81. Now this is a smooth surface, so there is no friction, only normal reaction will be acting. So it will be RA. And this is at an angle 30 degree. Now the tension which is acting away from the object, so it will be like this. And the motion here, what is the motion of the system? That means whichever weight is huge or massive weight, that will move downwards and the lighter one will move upwards. So here A will move downwards and B will move upwards. So the motion will be like this. This will be the direction of motion. So here also the direction of motion will be like this. So we will consider the equations. Since there is no motion in the y direction, so we are taking x direction along the inclined surface and y direction perpendicular to that. So since there is no motion in the y direction, we can say sigma Fy equal to 0, which implies RA minus 10 into 9.81 cos 30 equal to 0, or RA equal to 10 into 9.81 cos 30. Now the motion is towards the downwards. So here this is tension T. So by applying Newton's second law, we can say 10 into 9.81 sin 30 minus T, which is equal to mass into acceleration. That is, mass is 10 kg into acceleration A. Here acceleration of A and acceleration of B are same, because whenever whichever distance A is moving, that particular distance itself B is also moving, because it is connected by using a string. So the velocities are same and also acceleration are same. So let it be A in general. So we can write like this. Let this be equation number 1. Now considering the free body diagram of B, that is free body diagram of B. This is B, and the weight is acting vertically downwards. So the weight, which is equal to mass into acceleration, right? It is here, it is 5 into 9.81. Then the tension, T, That's the vertical reaction. This is RB, this will be RB. Okay, and the inclination this is 20 degree. Then since there is no motion in the y direction, we can say sigma Fy equal to 0 implies RB minus 5 into 9.81 cos 20 equal to 0, or RB equal to 5 into 9.81 cos 20. Then apply Newton's second law. By Newton's second law, here what is the direction of motion? This is the direction of motion, that is moving upwards. So this is the direction of motion, so that will be taken as positive. So T minus 5 into 9.81 sine 20 will be equal to mass into acceleration, and the mass is 5 and acceleration is same a, and let this be equation number 2. Now solving 1 and 2. On solving 1 and 2, we will get the values. T equal to 27.477 and the acceleration as 2.16 meter per second square. Okay, so these are the values. And next, a weight 4500 Newton is supported in a vertical plane by a string and pulley arranged as shown in the figure. If the free end A and of the spring is pulled vertically downwards with a constant acceleration 1.8 meter per second square, find the tension in the string. So here you have to find the tension. There is a pulley system arranged here, and we can see this is the movable pulley and this is the stationary pulley. So whichever weight you are acting here, the half of the weight should be on this point in order to make it in equilibrium, or we need only a half of the effort to raise this particular weight. That is, in order to lift the weight W, we need only W by 2 over here. And the acceleration, regarding the acceleration over the point A will be twice as that of the acceleration over here. That is, let the acceleration of the point A is AA and the acceleration of the weight is AW. Then AW will be only half of the value of AA. Okay. And here it is given the acceleration of the point A as 1.8 meter per second square. So what will be the value of AW? Just half of that, that is 0.9 meter per second square. This is the acceleration. Now you have to find the tension in the string. So in the string, let T be the tension. So the tension over this string, everything will be T. So while considering the weight W, you can see this pulley. This as we have done in the earlier problems. Here you are having two strings, T each. So altogether you will have a tension equivalent to 2T over this particular string. So in order to find the tension in the string or the T value, you will consider the free body diagram of W. So free body diagram of W. Okay. So weight W, then tension 2T. So since there is no motion in the x direction, you can say sigma f x equal to 0, which implies nothing is there. So 0 equal to 0. Now the motion is, it is moving upwards. So this is the motion. And so by applying Newton's second law, okay, we can write 2T minus W. W is given in the question, right? It is 4,500, which is equal to mass into acceleration. So mass means W equal to mass into G. So mass equal to W by G. So here it is 4,500 by 9.81. So mass into acceleration means 4,500 by 9.81 into acceleration value. And here the acceleration of W, it is nothing but 0.9. So substitute that value, then you will get 2T minus 4,500 equal to 4,500 by 9.81 into 0.9, and from here you will get the value of T as 2,456.42 Newton. Okay.